All right, so let's go ahead and build another vector notation, the one that I actually prefer, and I think you also will see in most applications. But it all starts with this concept of a unit vector. All right, oops, I'm getting my moving things around here. So the unit vector, what a unit vector basically is, right, as the name implies, this is a vector that has a magnitude, right? So if we let our vector v equal to 1, all right? So that basically means that I've got to find an ordered pair, right? On the, again, remember the AB is on the terminal side, right, of my vector v. So I basically have to find a vector, right, where a squared plus b squared equals 1, right? And conveniently, what we have is the unit circle, right? From chapter 3 and beyond, we have learned that any point x comma y, right, where x is equal to cosine theta and y is equal to sine theta, right, is basically on our unit circle. And of course, what do we know? Because the radius is equal to 1, x squared plus y squared equals to 1, because we know that cosine squared of theta plus sine squared of theta is equal to 1. And so basically, right, we already have the notation, right? So this point right here would be the point cosine theta sine theta, right? That's the ordered pair. But to make it a unit vector, and how about, since I'm calling it a unit vector, why don't I go ahead and use u, right? Our unit vector, borrowing our new notation, is basically our cosine of theta times our sine theta, right? And so this basically, as I kind of alluded to in the last video, is that this basically gives us direction, right? So our unit vector gives us the direction in which my vector quantity is heading. Again, maybe the speed of an airplane, the force due to gravity, the force I'm applying to something, right? If I know the angle involved, then the cosine of that angle gives me the x-coordinate of the vector, and the sine of theta gives us the y-coordinate of that vector, right? And so we have a unit vector, right? Cosine theta, sine theta. All right, so that is a pretty cool notion. So our unit circle being placed to work. It turns out that there are two very famous unit vectors. You'll see why in a moment. The first one through time is called the vector I. Usually we use a little hat on that rather than a little dashed line. But this is basically the vector 1 comma 0, right? And so essentially this unit vector, right, is there's a 1 unit and we end at the point 1 0. And so commonly we refer that to I, all right? And then basically the j vector is the unit vector, right, in the 1 component. Oh, by the way, in this case, theta is equal to 0, and in this case, theta is equal to 90, all right? And so those are our two famous unit vectors to help us do that, all right? And so, so again, coming back up to here, right, rather than calling the vector I keep using an ordered pair. So rather than using the vector AB, right, I can now use, I'm kind of getting into a new notation, I can use the vector AI plus BJ. And this is the unit vector component form, right? Because A is how much x action is going in the x direction, that the I component, and B is how much action's on the y coordinate, right, multiplied by the j, right? And you can see, because of what I have, I'm kind of getting into the scalar multiplication of this, right? If we use what I said there, what we eventually just have, right, that's 1 0. This would be a comma 0, and this would be 0 comma b. And so together we get AB, right? And I'm kind of jumping the gun. I just showed you vector addition, right, in that combination. But we now have basically two notations for our vector because of what we now have with regard to our unit vector. All right, so again, this one is the gold star. I like the AI and the BJ because it basically gives us the idea of what's happening in the X and the B, and we don't confuse it with any ordered pairs or anything like that. But choose what you will, I'll use both. All right, so there we have our unit vector, right, basically being described by our unit circle, right, good old cosine sine. Scalar multiplication. All right, well, with scalar multiplication, what we're doing, I kind of alluded to it in the little example that I have there, right, is when I take a vector, right, let me go ahead and just give you an example here, right? So it's when I have a unit vector, make sure my pen's on, right? So maybe I take 2 times the vector v. So this 2 is called a scalar, and we're multiplying it to the vector v. And so all that basically does picture-wise, if I have my vector v and it's this direction here, then to put on another v, right, I'll start here and go to there. So I'm kind of showing vector addition. So what I have together, right, this whole thing from here to here is 2v, all right? So we have scalar multiplication. In the end, what that means, right, if v is defined to be, let me go ahead and keep using this notation for the moment. If v is defined to be ab, then if I double that vector, right, what I get is 2a and 2b. And hopefully that doesn't surprise you, right, because there's a, and there's a, and there's b, and there's another b, right? And so that's called scalar multiplication, right? And you basically see, if we combine it, what I said up above there, right, if I basically have a unit vector and I multiply it by some scalar, let's call it k, then what I basically have, right, is k times my unit vector cosine theta sine theta. And lo and behold, what I have, if you go back to the earlier notation, right, I've got the magnitude of my vector v, right, times the cosine of theta sine theta. Oops, I keep going to the, right, and or in this new notation, right, we have my my vector v cosine of theta in the I direction plus my vector v, right, the sine of theta in the j direction. Okay, and so you can kind of see this basically ties us back to the last video where this guy right there is the unit vector, give me the direction that I'm going, and then the magnitude of v tells me how much size or how much I'm going in that particular direction. And so there's the example of 2. If I had a 3v, right, I'd be tripling this up. If I had negative v, right, I'd actually be going in the opposite direction. So there's negative v. If I had negative 2v, then I'd be going that, right, so there'd be another v direction. So that all together would be negative 2v. All right, so there's basically your scalar multiplication. And I kind of was a little sneaky there, right, in the process of giving you the notation. I also gave you, excuse me, in the process of explaining unit vectors, make sure my pen's on, for some reason it went off. In the process of describing unit vectors to you and scalar multiplication, it was pretty natural to come up with a new notation. So our new notation, let me kind of summarize that here. Right, our new notation after putting this all together is basically, rather than saying a comma b, right, what I will say is ai plus bj. And everything is basically an operation here, right? Our a is basically given by the magnitude of the vector cosine of theta, right? Our b is the magnitude of the vector, oops, I don't mean to, sine of theta. Our a squared plus b squared is equal to the magnitude of v, right? And that we know that the tangent of theta, right, is b over a, because we basically have, I probably should have drawn that picture, So again, I have the same, there's my theta, right? There's my ordered pair AB, right? But we have our new notation, right? How much of it is it acting along the x-axis? Well, that's AI. And how much is acting along the y-axis? Well, that's the BJ. But you'll notice everything else remains the same from our previous definition. So all we're doing is swapping back and forth between, this is called the standard, and this is the K representation, K being when we start throwing a K in there, that's basically 3 dimensions, right? But we're in 2 dimensions at the moment. Okay, so you'll basically see me working through both, right? But it basically boils down to, right, the fact that we're multiplying the magnitude, how long the vector is, to my unit vector cosine sine in order to get it. Alrighty, so there's basically a full-on introduction of vectors, how to describe them, and now we need to do a whole bunch more, but that's going to come in some videos coming soon. All right, talk to you later.